Good morning, everyone. Hope you're all having an amazing, morning, afternoon, night, whenever you're watching this. I'm making this in the morning. Sun's coming through the windows ever so softly. Hope you're having an amazing day. Couple of things here right off the bat. We're going to be discussing trig ratios of non-acute angles. Remember, non-acute means that it is bigger than 90, right? So far, we've been dealing with just a lot of acute. Well, today we're going to be learning about non-acute. So here's what we're going to do. And this is kind of getting into the big boy trigonometry, right? Big boy classes here. So, going through your non-acute angles, the first thing I want to do is look at your quadrants. Determine which trig ratios are positive in each quadrant. So in quadrant 1, remember you got sine, cosine, tangent, cosecant, cotangent, secant. Of all those, which ones are positive up here? If you remember, your x values are, your x values are positive. Your y values are positive. So x is positive, y is positive, your radius is positive. X is positive, y is positive, r is positive. Remember, r is always positive. So which ones are going to be positive up in here? Sine and cosecant all deal with your y value, positive up here. Cosine and secant deal with your x, all positive up here. Tangent is x over y, or y over x, which is positive over positive. Everything's positive up here, right? Flip over to this guy, all of a sudden your x is negative, but y is positive and r is positive. So think about which one is going to be positive here. Well, the positives here are going to be your y ones. Which ones deal with y? You've got a negative x and a positive y. Think about which ones deal with those. So you've got a positive sine of theta and the reciprocal of sine, which is cosecant. Down here you've got x is neg, y is negative, r is also positive. So x is negative and y is negative. Which one will be positive down here? Well, it's going to be a negative over a negative, which will be tangent. And cotangent. Remember, this is negative comma negative. Looks like a sleepy face. So that leaves over here where x is positive, y is negative, and r is positive. So which one will give you a positive value over here? The only positives are going to be cosine of theta and secant of theta, the ones that deal with x. Positive comma negative. So think about this. All of them are here. Only the ones that deal with y are positive here. Only the ones that deal with y and x are positive here. Only the ones that deal with x are positive here. Alright, so here's a little trick to remember this. ASTC. All students take calculus. And I know what you're thinking. Not me. Whatever. All students take calculus. All of them. Everyone will. So using that little thing we came up with, we can determine very quickly if an angle that they give us is positive or negative, such as the sine of 240. Sine of 240, where is 240 degrees at? Think about what quadrant 240 degrees is in. 240 degrees is in quadrant 3. And is quadrant 3 positive or negative for sine? Well, it's not positive because it's not one of these two, so it's got to be negative. Negative. Cosine of 5 pi over 3. 5 pi over 3 is in the 4th quadrant. Oops, excuse me. Write it this way, Q4. And is cosine positive in the 4th quadrant? Yup. And tangent of 150. 150 is in quadrant 2. And is tangent positive in quadrant 2? Nope, sine is. Okay, so pretty simple. Now read this box really quickly. It says the value of a trig ratio can be found using the reference angle and the sine for the quadrant. What? What? For example, sine of 330 degrees. If you were to draw 330 degrees, it'd be down here, right? There's 330 degrees. What's the reference angle to get you back up here? Alpha is 30 degrees, right? So what they're saying is that we can write it saying that instead of sine 330, it's going to be sine of 30 degrees. And is sine positive or negative down here? Is y positive or negative down here? Y is negative, so it's going to be a negative sine of 30, which is negative 1/2. Sine of 30 degrees is 1/2. You know that from your unit circle. Cosine of 5 pi over 4. What's the reference angle here? It's pi over 4. Question is, where is it at? 5 pi over 4 originally was here, because here's 4 pi over 4 plus 1 pi over 4. So your reference angle is pi over 4. And is cosine, is the x value positive or negative down here? It's negative. Here they're positive, here they're negative, so it's a negative cosine of pi over 4. And the cosine of pi over 4 is the x value at pi over 4, which is negative square root of 2 over 2. Alright? Let's keep going. Special angles can be grouped by their reference angles. Special angles can be grouped by their reference angles. Starting off here, if your reference angle is 30 degrees, like 30, 150, 210, and 330, that's what all of these degrees are right here. 30, 150, 210, 330. Go in and we can do what you call them? Ha! Brain fart. Radians. Thank you. Radians. We can do radians for these. This will be pi over 6, right? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Now I'm going to do these on the box very quickly, and then I want you to go back and label all of them on these circles on your own. So it's 45, 135, 225, 315. And we got 60, 120, 240, 300, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, and these angles, remember that these are all reference angles. These are all going back to the x-axis, right? What I'd like you to do is pause the video for a moment and fill in the rest of this stuff. Fill in the rest of these circles. Write down your degrees and your radians on all those angles. Moving on. On the back here, it says express each of the following in terms of a reference angle, then find the exact value of each trig ratio. Alright, so the sine of 225, what's the reference angle for 225? If you look on the front of your page, it's the sine of 45. 225 is in which quadrant? which quadrant? Well, 225 is in quadrant 3, and sine is negative in quadrant 3, so it's negative sine 45 degrees, which is negative square root of 2 over 2. This is doing all this without your unit circle. Sine of 120, what's the reference angle? Well, that's 60 degrees. And is 120 is in the second quadrant, sine is positive in that, so it's going to be positive sine of 60, which is the square root of 3 over 2. Cosine of 5 pi over 3 is cosine of pi over 3. I love finding reference angles for radians. They're so easy. It's just that, right? All right, and 5 pi over 3 is positive in the fourth quadrant, so it's going to be positive cosine of pi over 3, which is 1/2. Tangent of negative 135. Now, what negative 135 is in the third quadrant. That's going to be the tangent of 45 degrees. Oh, wow. Yeah, 45 degrees. Since it's in the third quadrant, it's going to be positive, which is 1. Cosine of 3 pi over 2. Remember, 3 pi over 2 is down here. Cosine of 3 pi over 2, the x value right there on the y-axis is 0. Nothing to do there. Tangent of 11 pi over 6 is going to be the tangent of pi over 6. 11 pi over 6 is in the fourth quadrant, so tangent in the fourth quadrant is negative. It's going to be the negative square root of 3 over 3. So just a little bit on the reference angles here. These take a lot of practice, so I'm not going to go very deep into these. We're going to do a lot of practicing in class on this one. So from here, let's just come to class tomorrow ready to go. Remember your reference angles, and please bring your unit circles. One thing that I would do on your unit circle, if I had one, I would show you. I should have thought of this, but one thing I would do at this point is to take your unit circle and fold it up so that all that you can see on there is going to be your first quadrant. Again, with the unit circle, I would fold it up so that all that I could see was the first quadrant. And if you do that, that is going to save you quite a bit of time on these reference angles. Everything that we do, a reference angles always deal with the first quadrant. All we're doing now is throwing signs in front of them. So on a regular angle, like the 225 degrees, the reference angle is 45 degrees. That puts it in quadrant 1. All these reference angles are all in except this one, are all in quadrant 1. Quadrant 1, quadrant 1, quadrant 1, quadrant 1, quadrant 1. So what you're doing is changing the angle to be in quadrant 1 and then telling me if it's positive or negative in the original quadrant. This was in quadrant 3. Sine is negative down there, so I'm going to change it to sine of 45, throw a negative in front. This was quadrant 2. Sine is positive there, so it's positive sine of 60. Positive sine of the reference angle. This is quadrant 3, tangent's positive down there, so it's tangent of 45. Tangent of the reference angle. Alright, bring these to class tomorrow. Bring your unit circles with you. And have a good day.